Hey everybody. So yesterday we introduced the concept of stoichiometry, and like we discussed in the outline from yesterday, that stoichiometry, mass and quantity relationships among reactants and products in a chemical reaction. And we discussed the idea that a chemical equation qualitatively describes a chemical reaction. It talks about what's there at the beginning and what's there at the end. What are the reactants? What are the products? And based on what those reactants and products are, we can just classify that reaction in one of these 5 ways. But when we get into stoichiometry, right, now we're talking about the calculation of quantities, looking at how much of a certain reactant is there at the beginning of a reaction, how much of a product is formed, and going from there. We showed yesterday how the balanced chemical equation, especially the coefficients of that balanced chemical equation, are very important in allowing us to compare a reactant to a product. Or what did we start with and what did we end with? And so we talked about that this conversion factor, the mole ratio, allows us to compare one part of an equation to another part of an equation. Reactants to products, reactants to reactants, whatever it might be. Now, that's great, and we went through and we talked about this balanced chemical equation and how we go from one to the other using the mole ratio. But generally speaking, moles are not the easiest thing for us to measure. Yes, they ensure that we have the same number of particles, so we're comparing apples to apples in terms of the quantities and the ratios of those quantities that are required, but measuring a mole is different for every object. So, generally speaking, we need to measure things in a more convenient way, and that's by measuring their mass. So today, we're going to focus on not just going from moles to moles, but going from mass to moles. And you'll see in your outline, this is the, I believe, the first example on the back of the outline that I gave you yesterday. You'll see that when we run through these sample calculations, this and this look exactly the same as yesterday. We start with moles of a given substance, we go and use the mole ratio, and we end up with moles of our desired substance, whatever it might be. But now we've added another step where we've included a grams measurement, because obviously that's a little bit more, that's easier for us to measure than it is to measure a mole of something, right, by counting it out. Measuring the mass in grams is much easier to do. So now we've added another step, and it's a step that we've done before. We've talked about the idea that a mole is always the same number of things, right? 1 mole of something is equal to 6.022 times 10 to the 23rd. And that's true of atoms, and it's true of ice cream cones, and it's true of school buses, and whatever. But in this case here, when we're generally speaking, when we're talking about these chemical reactions, we're talking about molecules, right? A group of atoms that have been joined together that are reacting with something else. So 1 mole is equal to 6.022 times 10 to the 23rd molecules. But there was a third part to this equation, or this equality, and that was the molar mass. And in the past, we just got the molar mass directly off the periodic table because we said that the average atomic mass is equal to the molar mass just in grams as opposed to atomic mass units. We're still going to make use of the periodic table, but now, because we're dealing with molecules, right, we're going to be dealing with more than one average atomic mass. And so we're going to have to do a little addition before we can use and get that molar mass for that substance. So let's get into this here, and let's look at this example underneath Roman numeral number 3. Part A says, when magnesium burns in air, a combustion reaction produces solid magnesium oxide. How many grams of magnesium oxide would be produced from 2 moles of magnesium? So let's go through this in an orderly fashion, right? First thing, what are we looking for? how many grams of magnesium oxide? Now, that means that we're going to go question mark grams. In case you don't do this off the top of your head, we can figure out what the formula for magnesium oxide is. In most of the examples, I will give you the equation that has the formulas. So I'm just going to tell you right now that magnesium oxide is MgO. And hopefully you could look at the periodic table, find where magnesium is and how many valence electrons it has, find oxygen and how many valence electrons it has, and figure out that that would be the formula. So we know what we're looking for. It told us that we have 2 moles of magnesium to begin with. Okay, now we've got something to work with here. But if we look back at our steps for doing these problems, and this is for mole-mole calculations, but the steps are pretty similar. The first step is to write a balanced chemical equation. And like I said, a lot of times I will have this for you already, but for our purposes, let's go through this. So it says, when magnesium burns in air, a combustion reaction, right? Hopefully we remember from our classification of reactions that combustion reactions are when something reacts with O2. O2 is one of those reactants. So it says when magnesium burns in air. So that means that we're going to have magnesium reacting with oxygen, because that's the combustion reaction, to produce solid magnesium oxide. So if it's producing solid magnesium oxide, right, we're going to put the arrow in to separate the reactants and the products. And I just told you that magnesium oxide has a formula of MgO. So there's the equation that represents the combustion of magnesium to produce magnesium oxide. Hopefully you can look at this and see that this equation is not currently balanced as it's written, but because it's a pretty simple equation, hopefully it's not too difficult for you to see how to balance it. We have 2 oxygens in the reactants, but we only have 1 oxygen over here in the product. Oh. So I'm going to put a 2 coefficient out in front of the magnesium oxide. That increases my oxygen to 2, but oxygen comes joined together with magnesium, so I'm going to have to add another coefficient over here to increase the amount of magnesium, and now we have a balanced chemical equation. All right, now let's get into what we're doing. So, right, stoichiometry problems are conversion problems. And like we've said before, conversion problems start with units that we don't want and lead us to units that we do want. So in this case here, it said we started with 2.00 moles of magnesium. Now, first conversion factor has to get rid of the unit we don't want. We don't want moles of magnesium, we want grams of magnesium oxide. So we're going to put moles of magnesium down here in the bottom part of this conversion factor. Now, like we said, conversion factors get rid of bad units and give us good units. But that would mean that we'd go here and put grams of magnesium oxide up on the top. But we can't do that. We can't compare moles of one thing and grams of something else, right? We need to compare moles to moles, because then we know that we have an equal number of things. Remember that this ratio, or this equation up on the top, through the coefficients gives us the ratio of the ingredients. But those ratios hold true when we're talking about moles. Well, they hold true when we're talking about molecules, but they also hold true when we're talking about moles, because moles is the same number of things, the same number of molecules. So here we need 2 magnesiums for every 1 oxygen. That's true if we have the same number of things, but not necessarily the same mass of things. So we can't have an equation, or sorry, a conversion factor that starts with moles of one thing and leads us to grams of something else. That doesn't work. But through the coefficients and the mole ratio that the coefficients explains for us, we can have a conversion factor that looks like that, that compares moles of one thing to moles of something else. Here we have a mole ratio. And like we introduced on Tuesday, we get the numbers from a mole ratio based on the coefficients from a balanced equation. So we look at our coefficients in our balanced equation. There's a 2 in front of magnesium, so I put the 2 there. There's a 2 in front of magnesium oxide, so I put the 2 there. Yes, it's 2 over 2, and that's 1, but for our purposes of going through the process, let's be consistent with what we're doing. So, if we wanted to do a little math now, like we said, we could put this over 1 if we wanted to, and moles of magnesium would cancel, and moles of magnesium would cancel, and that's great. But that leaves us with only one unit in our problem, and that's moles of magnesium oxide. But at the beginning, we established that this problem was asking us for grams of magnesium oxide, not moles of magnesium oxide. So we have a conversion problem that left us with a unit that we don't want. So what do? Another conversion factor. This second conversion factor must have moles of magnesium oxide on the bottom so that it cancels with the moles of magnesium oxide on the top of the previous conversion factor. And conversion factors get rid of bad units and lead us to good units. So we're getting rid of a bad unit, and we want to end up with our good unit, or the unit that we're looking for, and that's grams of magnesium oxide. Here we have another conversion factor that has moles on the bottom and grams on the top. But the difference between this conversion factor and the bad conversion factor that we were working with before is that this has moles of magnesium oxide and grams of magnesium oxide. We can do that. We can convert between moles of one substance and grams of that same substance through this equality, right? We know that these three things are equal to each other. We know we can go from moles to grams using the molar mass. Now, a little bit different here, because we don't just have molar mass of an element, we have the molar mass of a molecule. So if we go to the periodic table, you can find magnesium, you can find oxygen, and see their molar masses individually, but each molecule of magnesium oxide has one atom of magnesium, one atom of oxygen, so the molar mass of magnesium oxide is going to be those two masses added together. So up on the board I've got this periodic table, and it's not a full periodic table, but when I mouse over the different elements it gives me information. So here's magnesium, and you can see here that magnesium's atomic mass is 24.305. That might be a little bit different than that might be a little different than the molar mass that you have on yours, but there's magnesium, 24.305. Then I'm going to scroll over here to oxygen, and oxygen is listed as 15.99. Again, that might be a little bit different than what you guys got, but that's okay. So the molar mass of magnesium oxide is just going to be these two values added together. And so when I add those together, you end up with, hold on, let me grab my calculator. Stand by, calculating. End up with 40.295. Again, that might be a little bit different than what your periodic table says. The laminated periodic table is at the back of the room. Might be a little different. That's okay. That's fine. Okay? So, if we come back here, right, that is the molar mass of magnesium oxide, 40.295. Now, here's where things can get a little confusing. This last conversion factor is converting moles into grams using the molar mass. The molar mass is the mass of, like it says right on the screen here, 1 mole. It doesn't matter that there is a 2 coefficient in front of magnesium oxide in the balanced equation. That's what we use for the mole ratio. But when we're converting moles into grams using the molar mass, that's always on a 1 mole ratio. So whenever we have, or a 1 mole basis. So whenever we have a conversion factor that has moles and grams in it, moles of one thing and grams of that same thing, moles is always going to be 1. Whenever we have moles to moles, moles of one thing to grams of some, or moles of something different, sorry, moles of one thing to moles of something different in that equation, that's when we're going to use those coefficients. Keep that straight. That's where a lot of people run into issues. Now we can do some more math. All right, we would cancel this moles of magnesium oxide and this moles of magnesium oxide. The only unit that's left in our problem now is grams of magnesium oxide, and that's good because that's what the problem asked us for. So now we're just going to run our stuff through, right? We're multiplying 3 fractions together, so we multiply all the tops, multiply all the bottoms, right, and end up with tops over bottoms. So I'm going to run that through my calculator here. And obviously there are some ways that you can make this a little easier mathematically, and that's okay. I don't have any problem if you take those shortcuts, just as long as you're doing the problem right. So when I plug this into my calculator, I get 80.59, but looking back, and I didn't do this on Friday or on Tuesday because I was running out of time in my video and I kind of forgot about it. If we look, right, significant digits, there are 3 significant digits in the number that we started with. Mole ratios are just whole numbers, no significant digits we have to worry about there. Again, molar masses are defined values. Molar masses are defined values, so we don't have to worry about significant digits there. So our final answer should have the same number of significant digits as the number we started with. That's 3. So I should round this answer to 80.6 grams of magnesium oxide. So now we're getting a little bit closer to real life measurements. It's hard for us to measure moles. It's easier for us to measure grams. So now we've gone from moles into grams, and tomorrow, after you practice the sheet that you have for today, tomorrow we will get into going from grams to grams. We just add one more step onto this process. So you have the remainder of the period to work on these calculations. Answers will be posted on the calendar, so you have access to them to see how well you're doing. We'll come back on Thursday, and we will talk about the last type of problem and do some more practice. See you guys then.